Good morning, everybody. As Matt said, this is a joint presentation from me. I'm Jeremy Sharp. I'm Director of Strategic Technologies in Jisc, and the Jisc Technologies part of Jisc, and Martin Hamilton, who's the Jisc futurologist. I'll be concentrating on a little look back into sort of history, and history which Janet really played quite a significant part, as I'll sort of point out, and then move on to a few things we're doing now which hopefully sort of set some trends and signifiers to the future, and then Martin will talk about the real sort of future side of things and give a bit of food for thought. Okay. So a bit of back to the future. I guess to this audience, quite a few of you might be familiar or at least heard of some of these things. And what I'm going to sort of take you through is a bit of a, I suppose, journey that started in the sort of early 70s through to the present day. So CircNet was a private network that was established in the 1970s by one of the research councils then, and it was actually a network that joined the Daresbury and Chiltern, what's called now the STFC laboratories together, and that ran something called the Electronic Packet Switching Service Protocols, which was the world's first public packet network that was run by the post office as it was then, and that came into being at around 1973 and entered sort of public service really in around 1977. And by the end of 1988, 88, CircNet had become predominantly X25, which then was the precursor to what we know as Janet, with some of the other regional science infrastructures coming together, with Janet being created in around 1984. We had our 30th birthday last year. So X25 pads, that refers to, there was a version called the Camtech pad. Some of you might have remember those black boxes that were the X25 switches that we used a lot of on Janet, and they were very much a sort of a British built device. NSF sort of net relay, away from sort of X25. This was one of the sort of early email sort of systems. It was a mail relay, and Janet ran a few of these, and that was the method of people sending email on Janet and getting to the outside world through those mail relays. And they typically handled around 30 to 50,000 messages a day. I guess obviously those numbers are tiny, yes, but it was a lot back then. And that really lasted quite a long time and didn't come out of service until around 1997, so they were around for a while. And as I'll sort of come on to with some of these other things, the JNT as it was then was quite slow to change and adopt new things and plough its own furrow. Hopefully things are very different now. In terms of these sort of coloured books and the name relay service, the NRS was a precursor to what we know as the Internet DNS now, and the principal difference of that was that the significant bit of the name came first. So cam.ac.uk was uk.ac.cam, so that was the big endian first, and it was always written in uppercase. And one real lasting legacy in the UK of the NRS is that we have .uk as the domain name for Britain rather than .gb as specified in the ISO standard. And there's a really bit of interesting history there which you can look at in the History of Janet book that was published a few years ago. The coloured books, a real sort of bit of, I suppose, British networking sort of history. These were a set of protocols used by CircNet and Janet between around 1980 and 1992, and there are I think at least eight coloured books. And for example, the blue book was defined FTP. The pink book actually defined X25 over Ethernet. Grey book defined a protocol for mail and so on. So they were the early, so obviously precursor to the sort of internet protocols that we know now. How many of you sort of recognise the acronyms there, PP and QUIPU? Yeah, good, yeah, yes. When I started work in the, as was then the JNT, the Joint Network Team, there were about 20 of us back in the early 90s, and I worked with somebody called Jim Craigie. He was my boss at the time, and he was very much in the thick of writing some of the X400 standards, the OSI standards. Now, X400 PP was a ISO-D implementation of the X400 sort of mail implementation, and QUIPU was the X500 directory and LDAP standard. And moving on to sort of closer to what we know now, the Janet IP service and a project called Shoestring, which brought the IP service into operation. Now the Shoestring project was actually a trial of this new fangled thing called the Internet Protocol, and that one or two people, and Bob Day, I think, was very instrumental in the early 90s of really sort of pushing the JNT to trial IP, and it was initially trialled over the X25 infrastructure, and it was called Shoestring because there was no budget essentially for it, so people had to sort of beg, borrow and steal some new or some IP routers to actually run that trial. And that was established in around the autumn of 1992, that trial, and in sort of finally in the last quarter of around 1993, the IP service as we know it now became the officially preferred protocol of Janet. There were a lot of people sort of really holding out onto X25 and the older OSI standards, but a few of the newer and the younger people at the time in the JNT, Bob was one of those, really pushed the IP service. For those of you that want to sort of look into sort of the history, there's the UK Network Operators Forum. They publish some general internet history, and of course there's the Janet history book as well that Professor Chris Cooper edited for us a few years ago. Okay, a little look at some of the sort of broader technology. I guess a lot of you might remember the sort of vampire taps. These were sort of devices that pierced your 10 base 5 sort of Ethernet cabling that you connected one of these AUI, attachment user unit interfaces to, that you then attach your computer to. And again, before I started work for the J&T, I worked in the telecoms department of the Rutherford Appleton laboratory, doing a lot of the sort of physical wiring, and there was a system of villages in the different departments, and there was a backbone infrastructure, and a lot of the villages ran the 10 base 5 sort of infrastructure. So I sort of dealt a lot with the vampire taps and so building the early Ethernet networks. Trumpet WinSock was a technical specification around 1995 that defined how network software should sort of access network services, so TCP/IP. Very important bit of software, and the person that developed it, quite an interesting bit of history, a chap called Peter Tatton from Tasmania in Australia. He didn't make anything out of it. Very different to the days now of the internet sort of Wild West. His sort of software was distributed by a lot of ISPs in the sort of the magazines of the day that you loaded onto your computer. And I note that there was a bit of a campaign really to recompense him for his early sort of pioneering efforts. Mosaic, NCSA Mosaic was one of the early web browsers, really credited with the popularity of the web in 92. And obviously things like Archie, Gopher, Waze were some of the early sort of navigation tools in the 90s. Wavelan, moving on down the stack a little, was one of the very early sort of wireless technologies, proprietary sort of technology, and those were very much the precursor to the 802.11 sort of standard that we know and love. So that was very much sort of early to sort of mid to late 80s. Okay, so if we sort of leap forward a bit and look at a real period from those early pioneering sort of days of early networks and the internet to some quite a bit of consolidation activity that happened post year 2000. Ethernet is one of those standards that just sort of keeps getting reinvented and developed, but the name still stays the same. So we saw a lot of sort of activity in that Ethernet standards world to bring us the sort of high bit rate gigabit Ethernet that we know and love and run now on our networks. So a lot of focus on cabling standards, which really sort of move things along from those early sort of thin wire Ethernet days. A big focus on sort of converging things like telephony, CCTV and so on onto single network infrastructures. We're probably not quite there today. Some very bold folks do run sort of telephony, CCT over single infrastructures, but there's still quite a bit of separation in some organisations. Obviously, wireless really went mainstream post 2000, built into sort of everything, every device. Big focus in in the university world around really putting network facilities into student residences, and lots of universities experimenting with different models of outsourcing or doing it in-house and so on. EduRoam really took off. That really took 5 to 10 years to get the sort of penetration and the maturity, of the system as we know it now. So that took a long time, and there was a lot of money, as some of you might remember, pumped into the system by the funding bodies in the various countries of the UK that went into building wireless LANs, the metropolitan area networks that turned into the regional networks that we know now, through things like the strategic research infrastructure initiatives that HEFCE ran, and those were really those programs were there to develop sort of infrastructure, but a lot of that money did go into developing networks in universities and campuses. And we're at the position now where the network is clearly sort of mission critical for absolutely everybody in our institutions. So moving on to try and draw out some sort of trends and signifiers here. The initial capacity of the Janet 6 network, I'll get a few frowns from my colleague Rob in the audience, I'm sure, at this number. It's a bit of a marketing number, but Janet 6 we built and came into operation now a year or so ago. It's got significant sort of scaling capabilities up to 8.8 terabits on any one link in theory, and we're tickling a fraction of that capacity at the moment. And I was walking up from the station with Jonathan, who from Jasmine, who's going to talk next, and hearing about some of the exciting sort of floods of data that he's wanting to push out over the network. And what I really say to everybody is bring it on. That's why we built the sort of network that we built, is to support that type of activity. I think we still see the network roughly doubling in terms of usage every 18 months from the year dot. That still seems to be holding up now. And as we sort of keep pace with that, obviously the market and the cost per bit tends to roughly stay around the same, which allows us to sort of grow and scale the network within sensible budgets. I think it's 28, probably a little more than that, I think, Martin, isn't it? 28 years of uninterrupted service from Janet.
It's an old graphic.
Yeah, that's right. 2 years old, yeah. Or 3 years old. We hit our 30th birthday, 1984. Janet formally came into being. Around £30 million of investment that went into Janet 6, into the core and supporting the development of obviously the regional infrastructure, and around 18 million Janet users. What I'd like to sort of move on to really is, apart from the network, which, we've got something that's really state-of-the-art using today's sort of technology. Jisc has been concentrating in supporting your activities in other areas. And a really important bit of infrastructure that we've put in place that should really add value to a lot of universities is the shared data centre. And this is a rather stretched but an actual picture of the data centre that we've procured in Slough, or as we like to say, Upper Windsor. It has a nicer ring to it. And this was around £900,000 worth of investment by HEFCE to put this data centre right on the core of the network. So it's connected initially at 100 gigabits, and we can scale that up as this gets used more and more. It's a significantly large facility that we, as sort of sectors that use Janet, can grow into. And we worked with, and this procurement was very much driven and shaped by the anchor tenants that are now very rapidly moving into this data centre, and we were latterly joined by Imperial College, and we've got a whole pipeline now of universities beginning to sign up and moving their equipment in. And what we're seeing is, this obviously caters for very high-end HPC type of requirements, so it can cope with that high-density sort of power and cooling requirement, right down to the sort of enterprise sort of systems that institutions sort of use. So if you want to know, so that's very much a different talk. If you want to know more about that, have a look there, or come and chat to me. We've been doing a lot of sort of work, again driven by what the sort of Janet users, customers sort of would like in terms of their outsourcing agendas and using the cloud. And one recent example of that is what we've done with Amazon in terms of providing the Amazon Cloud portal, which gives a very sort of tailored to the sector way of taking some of the Amazon services, and very importantly gives that sort of volume discount through aggregation across the sector. A principle we used in the shared data centre: the more people that use it, the lower the prices for everybody within the framework. Moonshot, a bit of technology that has been invented within the sector, and this is obviously what we call in summary a single unifying technology for access management, very much driven initially by the use case for access to non-web-based services, and typically sort of HPC SSH access. But it does, with the technology it uses, have a broader application for the web-based sort of access management technology. We use Shibboleth at the moment, and Edurome potentially as well. And so we're looking at this technology as a converging sort of technology in the future. And we did a lot of work within ITF, under the ABFAB working group, as it's called, to standardise the Moonshot technology. And you probably heard it here first, but the service launch that will happen in April will be called Ascent. Can
we tweet that?
You can if you want, yes. I'll probably get shot, but as I've said it, I'm sure people have already tweeted it. Okay. I think another important sort of area, and we work increasingly closely with government now, and one of sort of their visions is an e-infrastructure for the UK, not just for academe but also for industry. An e-infrastructure that brings together experimental facilities, high performance computing, on a highly capable network, and Janet is really seen as that underpinning network for the UK, both for industry and academe, what is badged as an open, accessible network to industry. So we've had a bit of funding from BIS to look at how we can make that available to industry, where industry has a requirement to get to some of the sort of resources that sit on the network, some of the high performance computing resources, some of the sort of expertise that sort of sits in universities. And we have a scheme that's very much modelled on Innovate UK, or the TSB as was then, some of their processes that helps us manage the state aid issues around connecting industry into Janet. And we've got now 5 or 6 industry players now under this scheme connecting to Janet. One of those is Rolls-Royce, as they collaborate with a number of universities. Another sort of trend we're seeing, obviously a lot of emphasis around security, around information security. we're working very closely with the biomedical community, who obviously have a requirement to access data sets, bring those together, and sort of to support their research. Those data sets, some of those are potentially contain patient identifiable data, so very sensitive. Last thing we want is a Daily Mail story. Janet sort of exposes sort of Fred Bloggs' patient records or whatever. So we're looking at how we can provide assured networking to those scientists that want to move around data sets. So we're establishing an encrypted VPN overlay infrastructure over Janet, providing enhanced confidentiality and integrity as per ISO 27001. And we're working very closely with the FAR Institute and a number of other organisations. And what we hope is that this will lead to a product that we can provide to others that need it. We're starting to see a requirement for this type of higher assurance service, if you like, in other areas. Very sort of briefly, some other areas. This is an equipment sharing initiative that we're running within Jisc, and this is sort of brokered access to public investment in HPC. And it's also about creating a directory of very expensive equipment, whether it's a mass spectrometer or a wind tunnel that exist within the UK, and where others want, where people want to actually share those facilities and potentially get a bit of revenue for that. So that's one initiative. So if I can sort of conclude my part, and I'll hand over swiftly to Martin. So we've done a lot of work over the years. There's been a lot of focus on the network infrastructures, whether that's been, from a Janet perspective in the wide area, or what you guys do on campuses. And the emphasis now, whilst we're not taking our eye off the ball on the network and developing that, a lot of emphasis is being placed on what the network enables and the broader value. A lot of emphasis on sharing facilities, whether it's the data centre, whether it's sort of equipment or brokering access to HPC, which should reduce the friction of collaboration. Those anchor tenants in the shared data centre, some of the projects are joint research projects. There's a project called eMedLab, joint between UCL-SANG and CRIC, and they have put some shared HPC that they've bought, shared storage in the data centre. And with the other anchor tenants, we're talking about shared network infrastructure in the data centre, and shared storage, shared sort of backup tape. They're going into this with a very open mind. Clearly, and again, I think Jonathan might sort of talk about this in his talk. We are seeing, and will increasingly see, astronomical volumes of data from some of the big global research endeavours, and they are global. LHC, SKA in years to come in radio astronomy, and obviously the work in the biomedical area as well. I sort of hinted how we're working very closely with government and industry as a whole, and we're doing a lot of sort of joining the dots in the broader R&D sort of landscape within the UK, within Europe, and globally as well. So the network itself, it's almost a question really, which I'm sure we'll be sort of covering today. Is it a done deal, or is there a further period of rapid evolution to come, as we saw in the 70s and 80s?
Well, thanks. So I'm conscious we're running a little bit behind time, so I wonder if we could steal 5 minutes from the coffee break. I'm looking at Matt here. Would that be okay? He says, we'll see how it goes. Okay, I'll talk quickly. So where I work in Jisc is at the head of the pipeline, if you like. So I'm meant to be looking at what's next, what could be coming in the future. We talked about lots of things that are in place now or being developed now, which some of you will be aware of, some of the stuff that Jeremy's just talked about. But let's imagine, take a completely different tack. Let's imagine that you're sitting on the board of Ford Motor Company or VW or something like that, and you think about a new technology like autonomous vehicles, driverless cars. You might say, well, that's years away. But actually, those things are going to hit the streets in the UK this year. In Milton Keynes, there'll be driverless car pilots. And Elon Musk recently announced a partial autonomous mode for his Tesla cars, which is a software upgrade. He said all the hardware is there already. Can you imagine waking up, if you're on the board of Ford Motor Company, and discovering that this guy who you thought was pretty irrelevant, he's just downloaded an update that makes all his cars overnight autonomous vehicles. So there's some quite disruptive things coming along. And you might say, well, okay, that's autonomous vehicles. We're networking people. We don't really care about those. But let's say, pick an example perhaps that's closer to home. 5G communications right now, no one really knows what that is. It's a grab bag potentially of technologies, massive MIMO arrays, millimeter wave antenna, lots of stuff that could be part of 5G. But there is a vision for it, which this is stolen from the likes of Huawei and Samsung and China Telecom. The vision is remarkably attractive for people like us. If you had to build a campus wireless network, wouldn't it be great if you could just plug into something that was designed to cope with masses of users, with massive bandwidth and very low latency? Wouldn't that be good? And maybe that will come. That's being prototyped now. Is anybody here from Sussex? So any hand up? If you're at Sussex, this is being prototyped on your campus. So I was hoping someone put their hand up and we could get them back in next time to tell us how that went. So the interesting thing, we've got all these new technologies and initiatives that we're looking at today. But for me, the question is, how do we fit in? What can we do? And we have this tendency in institutions to think of IT as a cost centre. It's a drain on resources, it's a chore, I really don't want to have to spend money on it if you're university senior management. I don't like this, can I just keep it to a minimum? What would Tesco say? What would Amazon say? They don't say, oh God, IT is such a drain on resources. They say, how are we going to best exploit this? We had some great examples earlier on of how networking was really at the forefront of innovation, and we've touted a few things that we're doing that we think are quite innovative. But I think that there's a huge opportunity for folk in institutions to be a part of that innovation and to be working with their researchers. And I think if you look at the technology like software-defined networking, you used to have to wait for the new silicon. You used to have to wait for Cisco to produce you a new supervisor board. The idea that you can download an algorithm into an FPGA on a white box SDN system, that's hugely interesting because it means we can prototype all kinds of new stuff that were simply inaccessible to folk like us. The network became progressively less accessible to us, and all of a sudden that's opening up again. So I think that's really interesting. But my closing point here really is that question there. Are you doing something that gives your institution a unique selling point or some kind of special advantage? It would be really good if you were, and perhaps some of the technologies that we're going to talk about here today could be a route into doing that, a route away from commoditization, outsourcing, perhaps we don't really even need a network team, to really embedding the network as the heart of the innovation that the institution is doing. So that's the final bit of our talk. Thanks for the indulgence.
Absolutely.
And a quick plug for Network Shop, if you haven't signed up already.